Yeah, this is the competition. Accept the rules. Late submission.
Okay, I accepted the rules. Now if I try,
Do not get that error.
yeah, I think it's well, let me try again. It's working, I think.
Yeah, good, good.
So for some of the other notebooks, I think it was not mandatory, right? Earlier the last the previous
So
class
for
we
every competition in Kaggle, it's mandatory. Most of the competitions, 95 to 90% will have one or two may not have that requirement. But 95 to 95 competition, you have to accept the rules. Even if the competition is over, you have to accept the rules.
got it. Thank you.
Yeah. So no one else is having any doubts. You have to do final evaluation. So image classification, if you are not having doubts, then how will you do that? See,
One
codes and all you have to practice every day. See, the way you practice this, it will be overwhelming. Each and every line you have to sit and try to understand, print out what is output coming at each phase. Practice, 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 practice. That's how it will come. The more you practice, the more you will get familiar. No matter how much theory you learn, if you don't know how to solve the real world problems, there's no use. You have to practice a lot of data sets. So anyone else has doubts? 3 more minutes left to start the next use case.
one more thing, I was trying to run this. I copied this and trying to run this in
Able
the.
to see your screen.
Okay. So I'm trying to run this, but I'm not able to import this Kaggle data sets. So I'm not able to connect to Kaggle properly.
Yeah. GoLab, you have to do a lot of changes. You have to install that Kaggle datasets API and all that. There's a lot of procedure you need to do in GoLab. It's the best idea to run in Kaggle only.
Okay, thank you.
Some steps are there which many people have written Medium articles on. You can follow the steps to run it in GoLab.
Yeah, I was trying to follow that, but okay, I'll run
Kaggle
in.
datasets API and all you have to install. Then that secrets will be there. Kaggle secrets for every account that you have to take. Some procedure is there.
Yep, yep, got it. Thanks.
Yeah. Okay, the last use case of the session, I'm going to take a simpler toy data set, explain the same concept. How to use flower classification on TPU. This is a bit easier data set, so if some people are struggling to understand those use cases, you can get started with something simple like this flower classification. Once you understand it thoroughly, that competition link and both the notebook link I have shared. Once you understand this thoroughly, then you can move on to the bigger, the melanoma classifications and all that. Still, many of you are not comfortable with image classification. We have discussed more than 5 use cases. So here the F1 score, macro F1 score is the metric, and the data we are given as the flower data set. So the flower data set is already converted to TF records. So you have training TF records, validation TF records, test TF records. You have unique ID and what kind of flower it is. This is what is flower classification example. This is a very basic example. For because some people are not answering, it means you are not able to understand. So I'm going for some simpler data set. So first try to understand this very basic, simpler toy data set, then slowly go for the tougher examples which has been covered earlier. So getting started with this. So similarly, you'll have be importing all the libraries and functions, the metrics and all of that. The TPU, I told you there will be a standard piece of code. If you want to use TPUs, you'll use a standard piece of code, which is you will initialize a TPU cluster resolver object, then you'll connect to it, and then you'll initialize the TFT the strategy API. So these are some set of procedures which you need to do for TPU detection. Kaggle datasets are available in GCS path, so you can get at the Kaggle particular dataset TF records for using TPUs. For then once you get the direct path, these are the flower species which you need to classify. Now the same utility functions, that is decoding images and some utility functions and all for displaying visualization. There are a bunch of utility functions. Here it is the data set. The same functions we have seen earlier as well, decoding the image, reading the same thing. You can cut, copy, paste in every time you write. You don't have to type. You can just cut, copy, paste. Reading the TF records, reading the unlabeled TF records, and loading the data set, getting the training data set, getting the validation and test data set. Some parameters and all you're configuring here, where it is the number of training images, number of validation images, number of test images, steps per epoch, and all that. You can visualize some of the flowers and see. Now this is the model. This is where strategy.scope. This is where the TPU initialization starts. CPU starts working. So you have a lambda layer, PGG16 pre-trained model. Then you are just adding one pre-trained model. You're just adding, global average pooling and dense layer to it. Then you're compiling the model, and then you're fit training it, fit and observing the loss, model accuracy, confusion matrix, predictions, then visualizing the predictions as well. So this is a similar example. Everything is same. The creation of TPUs, creation of TF records. The TF records is already given to you as a part of the data sets. So here also you are using TF.data API. Then you are using fine tuning. You are using transfer learning, and then you are just making predictions. You are just fitting the model, training the model, and then making predictions. Similar thing. Well, the use case is very very similar, but this is a bit of a toy example, so you can get started with this flower classification if you find it very difficult to follow each and every line, set and print. First time nobody will understand it. You have to go through the code over and over again. Lot of hard work in the beginning. Once you get a grasp of it, then you'll be all set to go. So initially, to understand codes, you have to work very, very hard. How many of you are awake in the class now? Six people, seven people. So go through the TF records till 5 p.m. If you have any doubts, you can now start asking. This is the last use case for today. We have finished that use case. If you have any questions in TF flowers use case, you can ask. I'll wind up by discussing the research papers for object detection. Whatever people who are interested in research, what are the research papers you can look at. With that, we'll be winding up the session. Till 5:30, go through that notebook, and if you have any questions, try running it in Kaggle notebook, printing out every line and seeing what you're not able to understand on all that things. You can try experimenting with it.
Ma'am, one question here in the on the pre-trained model, we are saying trainable is false. Um,
What?
so on the pre-trained model, when we are trying to create the model, uh, we are fetching a pre-trained model, and then we are saying it setting the trainable is equal to false.
Okay.
So uh, so can, if in case I need to add some more images, I can set this as true and then add more label and more classes and some different flower images and use the same model. Is this feasible with this?
Where did they include top is equal to false? That's what you're telling, right?
Um, no, no. I mean, is in the model section. If you on the notebook, if you go to the model section on the table of contents.
Mm-hmm. Yeah, I'm in the model section only.
Yep. So uh, towards the end, there is model dot summary, and before that, model dot compile, and before that, it is setting the trainable property as false.
Or trainable is equal to false. So
Yes.
you're freezing the weights of the feature engineering layers. You're freezing the weights. You're not training that. You're
Okay.
only training for the classification layers which you're adding. See, I told you two things, right? One is the feature extraction layer where you have convolutions, max pooling, and all that, and then you have fully connected layers. First thing you're doing is you're chopping off the fully connected layers, and then you're adding additional layers. So I'm freezing the weight of those feature engineering layers, which is the convolution layers and those kind of layers, those front layers. I'm just freezing the weights. I'm only training it on the last few layers which I added, which is the global average pooling, Keras layers, one five fully connected. Only these last two, three layers I'm training.
Okay. Got it. And other question is that I mean, in this code we are defining the initializing the classes variable manually. So there are so many classes and we have to write so many class names.
No, this is only dummy code. For you to understand this, the author has written like that. It's not necessary you should do it the same way.
Okay.
You have multiple ways to do such things. You can follow the way which is more optimal and things like that.
So how to save from writing the class names, ma'am? So the images name are there, and they will also contain the say flower name in this case, or the class names. So can I
You
extract?
can write a JSON file and then you can read it from the JSON file. You can do the mapping also. So there are multiple ways you can do such mappings. You can create a dictionary and map it also, where you can map the numeric value to the class names. But whether you create it in JSON or whether you create it manually, a dictionary, whatever it is, at some point you have to create that. But you can do it in an optimal way which you like. You
So I
have to, even if there are 50 classes, you have to mention all the 50 classes, but you have to map that 50 classes to a numeric value. That you have to do for sure.
okay, and when there is a data set, so aren't we expected to get the names of those images, and from those names we can deduct the class names?
I didn't get the question.
So there is a training data set, and so that data set will contain the image, object, and also the name of the image as well. So from that name I should be able to get the class name as well.
So here you are getting TF records, right? TF records will contain both the images and the corresponding labels. That's how we'll create TF records. TF record is a storage format. But if you are not having TF records and if you are having image file, there will be a separate folder for images, under which you will have a train folder where you will have training images, separate folder for labels where you will have the corresponding labels for train. Like that only you will have. Here they have already given you in TF records. TF records is a contains both metadata and the labels and the image files.
Okay. So thanks. I didn't know that about TF
Yeah.
records.
So anyone else has questions? Some of the research papers which you can try going through are your CenterNet paper is there. CenterNet has one mini Kaggle computations and the implementations of CenterNet also is here. We have 14 more minutes to wind up. Context RCNN is also a very interesting paper. I'm sharing some research papers for you to explore after the session. TensorFlow implementation is available. Ten more minutes. If you have any questions, if you don't have any questions now, how will you do your final evaluation? If you understood, you will ask a lot of questions.
There is a lot to digest actually, Usha. This is a lot of information. We need to probably go through it more.
Yeah. Next week also I will be revising a couple of image classification examples because that is your final evaluation. The more you listen to TPU, the more you listen to all this over and over again, it takes some time. But if you just listen to class, nothing will go. Nothing will happen. If you have to go practice it, the more you practice, that is when it will come. Real world data sets take practice, then you'll become perfect in that. We'll be winding up at 5. There's 10 more minutes for questions. If you have questions, you can ask. Otherwise, can somebody summarize what all we discussed today from morning? So we started off with the object detection. We saw YOLO object detection, basic object detection using YOLO inference, then custom object detection using YOLO. Then we saw a couple of real world use cases, Great Barrier Reef. We saw also global weed detection. And then we started with TensorFlow object detection API basic one. Then we saw TensorFlow object detection API using we also saw that is with efficient data backbone. We saw what to say how to do for the same use case in the morning, which is Great Barrier Reef. And then we also saw different TensorFlow ecosystem tools like TensorFlow Lite, TensorFlow JS, TensorFlow Extended, and all these TensorFlow ecosystem tools. And then we discussed a couple of use cases in image classification, which is flower classification. And then we also discussed melanoma Lessian classification. There's a lot we have discussed from morning. Do spend time sometime tomorrow to go through all of it so you become more comfortable. All right, it is 5 o'clock. So you can all wind up for today. We'll catch up next week.
Thank you.
Thank you. Bye bye.
Thank you.
Thanks,
Thank
Monica.
you.
Bye.
Thank you.
Thanks,
Bye.
thanks, Usha.